Good morning. Hope you're okay. Welcome to our lecture. And our lecture is on the topic sampling and sampling distributions. Okay, so this was prepared by my colleague. Okay, so at the end of this discussion, you should be able to describe a sample, a random sample, a simple random sample, about sampling, descriptive and inferential statistics, should be able to describe sampling distributions, the mean standard deviation of a sampling distribution of sample means. Okay, you should also be able to describe the central limit theorem and its importance. Okay, then you should be able to deal with the sampling distribution of sample sample proportions and sampling distributions of sample variances. Okay, so all the topics that we have done so far were mainly on descriptive statistics. Okay, but as we begin sampling distributions, we're getting into inferential statistics. Now, these were explained earlier, what a population is and what a sample is. We know that a sample is just a part of a population. Okay, one would wonder why we need to take a sample. Okay, now a sample is less time consuming, okay, and also less costly. The good thing about taking a sample is that we can actually know or have a conclusion of the whole population just by using a sample. Because even when you are testing food, you don't need to eat the whole pot for you to know that there is salt in that pot or in that relish. Okay, so we can actually make conclusion with high precision based on samples. Now, a simple random sample is just a sample in which every object, every member of the population has an equal chance of being selected. Okay. Okay. So I talked about descriptive and inferential statistics. So we know I gave you a definition earlier in the first lecture that inferential statistics is actually just concerned about making conclusion or decisions of a population based on a sample. Now, as we make decisions or conclusions, we can use estimation or hypothesis testing. Okay, so that was all about samples and sampling. We now start sampling distributions. Now, a sampling distribution is just a distribution of all possible values of a statistic. Okay? All possible values of a statistic for a given size sample selected from a population. In short, what we're saying is that the distribution of all possible values of a statistic. Now, a statistic is just a piece of information that you get from a sample. If you calculate your mean from a sample, then your mean becomes your statistic or sample statistic. If you calculate your median from the sample, then your median becomes a sample statistic. So a statistic is just simply a piece of information that you get from a sample. Now, in other terms, we would say that a sampling distribution is just a probability distribution of statistic. Okay, so we have sampling distributions of sample means, sampling distribution of sample proportion, and sampling distribution of sample variances. Now, here is a scenario of how